Have you ever wondered about the different types of powders and their properties? Today, let's uncover the fascinating world of powders and granules. These are not mere dust particles you find around your house. Oh no. They play a pivotal role in the field of pharmacy, serving as unique dosage forms. Imagine a world where all medicine is liquid or injectable. Not very convenient, right? That's where powders and granules come in, offering an easy-to-use, flexible alternative. But they're not just about convenience. These tiny particles possess intriguing properties that make them suitable for this role. Ever thought about how they flow? It's not as simple as you might think. Their flow properties are of utmost importance and are meticulously measured. By now, you must be brimming with curiosity, so stay with us as we dive deeper into the world of powders and granules, their types, properties, and much more. So, what are the different types of powders we encounter in pharmaceuticals? Well, in the world of pharmacy, powders are finely divided solid substances that play a crucial role in the formulation of various medicines. They come in all shapes and sizes, each with unique characteristics tailored to specific uses. First, we have bulk powders. As the name suggests, these are powders that are dispensed in bulk quantities. Rather than being taken in a single dose, bulk powders are often used over time. A common example is the milk of magnesia used in antacids. Next up, we have divided powders. These are individual doses of powdered medication, usually wrapped separately in small papers or capsules. These are particularly useful when the medication is potent, and precise dosing is critical. An example of this would be the powdered form of the antibiotic erythromycin, which is often dispensed in divided doses to ensure accuracy. Then there are dusting powders. These are intended for external use, often applied to the skin to reduce moisture and friction. Ever heard of talcum powder? Well, that is a classic example of a dusting powder. But wait, there's more. We also have effervescent powders. These are fascinating as they fizz when they come into contact with water. This reaction results in a solution that can be easily consumed. An example of this would be some forms of vitamin C supplements, which dissolve in water to create a tangy, effervescent drink. Lastly, we have insufflation powders. These are fine powders intended for blowing into body cavities. A common example is the powder form of antibiotics that are blown into the ear for ear infections. As you can see, the world of powders in pharmaceuticals is diverse and fascinating, each type carefully designed for a specific purpose. Now that we know the types of powders, let's explore their intriguing properties. What makes powders unique and useful in pharmacy? A question worth pondering, isn't it? Well, the answer lies in their properties. Let's delve into them, shall we? First up, particle size. This is a critical factor that influences the behavior of powders. For instance, finer particles have a larger surface area relative to their volume, which can enhance their dissolution rate. This is particularly useful in pharmacy, where rapid onset of action is often desired. Next, we have density. This refers to the mass of the particles per unit volume. It's a key player in determining the amount of active ingredient that can be packed into a dosage form. A higher density means more drug can be incorporated, which can be advantageous in creating high-strength doses. Then comes porosity, the measure of the void spaces in a material. Highly porous powders can absorb liquids and gases, which can be beneficial in certain pharmaceutical applications. For instance, powders with high porosity can be used to deliver volatile drugs or to create dosage forms that rapidly disintegrate in the body. Lastly, we have solubility. This is the ability of the powder to dissolve in a solvent, such as water. Solubility is a vital aspect in drug delivery because it affects the rate at which the drug becomes available for absorption in the body. These properties don't just exist in isolation. They interact with each other to define the overall performance of the powder as a dosage form. For instance, a powder with small particles, high density, and low porosity might dissolve quickly, but might be difficult to handle and dose accurately. On the other hand, a powder with large particles, low density, and high porosity might be easy to handle, but dissolve slowly. Understanding these properties is important, but so is knowing how to measure them. But that's a topic for our next scene. So stay tuned as we continue to unravel the fascinating world of powders in pharmacy. Why should we care about the flow properties of powders? Now that's a question worth pondering upon. You see, in the world of pharmaceutical manufacturing, the flow properties of powders play a pivotal role. They influence how the powders are processed, how they behave during manufacturing, and ultimately, the quality of the final product. So, when we talk about flow properties, we're essentially referring to how easily a powder can move or flow. This determines its ability to be transported, mixed, and packed. A powder with poor flow properties could lead to uneven mixing, inconsistencies in dosage forms, or even issues with packaging. That's why understanding and measuring flow properties is so crucial. So how do we measure these properties? There are several methods employed in the industry, each with its own merits. Let's delve into a few of the most common ones. First up, we have the angle of repose. This is the maximum angle at which a pile of powder can remain stable without sliding. The steeper the angle, the poorer the flow. This method is simple and straightforward, but it's also somewhat subjective and can vary with different operators. Next, we have tapped density. Here, a known volume of powder is repeatedly tapped until no further change in volume occurs. The final volume is then used to calculate the tapped density. This method provides a measure of the powder's ability to settle, which can be useful in predicting its behavior during transportation or storage. Lastly, we have the shear cell method. This involves applying a known shear stress to a powder sample and measuring its resistance to flow. This method is considered the most accurate and reliable, but it's also the most complex and requires specialized equipment. As you can see, the flow properties of powders are not just a trivial matter. They are fundamental to the successful manufacturing of pharmaceutical products. Flow properties are crucial, but equally important is the art of mixing these powders. So stay tuned as we delve into that exciting topic next. How do we ensure a uniform mix of powders? Well, let's dive into the fascinating world of powder mixing and evaluation. When it comes to mixing powders, the goal is to achieve a uniform distribution of ingredients. This is crucial for both safety and efficacy. To achieve this, we utilize a variety of methods depending on the nature and quantity of the powders involved. Firstly, we have spatulation. This method is ideal for small amounts of powder and involves using a spatula to mix the powders on a sheet of paper or an ointment slab. It's simple but remarkably effective for achieving a homogeneous mix. Next up, there's trituration. This involves grinding the powder in a mortar with a pestle. It's a method mostly used for reducing particle size, but it also helps to mix powders thoroughly, particularly when there are only small amounts of active ingredient. Then there's geometric dilution, a method used when there's a large difference in the quantities of two powders. It involves adding the lesser quantity powder to an equal amount of the larger quantity powder, then doubling the mix until everything is combined. It's a method that ensures even distribution, even when the ingredients are at vastly different quantities. Now, once we've mixed our powders, we need to evaluate them. This involves assessing the quality and performance of the powder mix. We look at several factors such as flowability, which is how easily the powder flows, and compressibility, which is how readily it forms a compact mass. We also assess the particle size distribution and the powder's ability to mix with liquids, among other things. These evaluations help ensure the final product is safe, effective, and of high quality. It's a meticulous process, but a vital one, as it directly impacts the performance of the dosage form. So, that's a brief overview of the methods of mixing and evaluating powders. But as we delve further into the world of pharmaceutical powders and granules, we find that powders have their place, but there's another form that's equally important: granules. What are granules and why are they important in pharmacy? Granules, my dear friends, are a real game changer in the pharmaceutical world. Imagine them as tiny, compacted particles of powder. They are essentially aggregates of finer powder particles. But why bother with this extra step of creating granules when we already have powders, you might ask? Well, granules offer several advantages. They flow better and are less likely to cake or clump together, which is a big plus in manufacturing. They also tend to dissolve more uniformly, which can improve the consistency of dosing. Now, how do we transform powders into these useful granules? There are primarily two methods: wet granulation and dry granulation. Wet granulation involves the addition of a liquid binder to the powder, followed by drying and sieving. Dry granulation, on the other hand, uses pressure to compact the powders into granules. So that's a brief overview of powders and granules in pharmacy. Remember, these forms are everywhere, from the talcum powder you use to the effervescent granules that fizz in your drink. And there you have it, a quick tour of the world of powders and granules. We've explored the different types of powder dosage forms, their properties, flow measurements, mixing methods, and the significance of granulation. Remember, understanding these dosage forms is key to mastering the art of pharmacy. It's a fascinating journey that combines science, precision, and creativity. So stay curious, keep learning, and don't forget to subscribe for more.